Coach Goo here, and we are back with a final topic for this unit with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. This is notes number 4, solving systems of equations using elimination. So we've learned how to use graphing to solve systems, but graphing is tedious, and some of us suck at drawing lines, let's just be honest, and it doesn't work very well when solutions are decimals or fractions, right, because you can't exactly tell where they are. Then we've learned how to use substitution, which is nice when it's easy to get a variable by itself, but if not, it can actually take a lot of work. So now we're going to learn the final second algebraic method, but third method overall to solve systems, and it's called elimination. So with elimination, we can eliminate one of the variables by adding or subtracting whole equations. Sometimes you have to multiply one or even both of the equations, though, by a number to get variable terms that you can eliminate. And so the best way to demonstrate this is with some examples. So let's go into example number 1. Alright, so example number 1 is really going to walk you through the steps of elimination. So check out this system of equations right here. 4x plus 2y equals 9 and negative 4x plus 3y equals 16. Now look at this little thought bubble thinking. One of these equations has 4x and the other has negative 4x. We can add to get rid of x. Think about it, we have two equations, one is 4x and one has negative 4x. If we add those equations together, the 4x's will just cancel out. Watch, if I just add these together, 4x plus negative 4x, that just cancels each other out. Boom. Then 2y plus 3y is 5y. And then 9 plus 16 is 25. And look at that, with one simple step, we've already completely isolated a variable and we can solve for it right away. So I want to solve for y now, because it's by itself on one side. What am I going to do? Divide both sides by 5, and that tells me that y equals 5. Dang, that was quick! I already solved for one variable. So now that we've solved for a variable, what can we do? We're just going to plug this 5 in for the y into either equation, and then we can solve for x. So watch this, my original equation, let me erase this so I can see it. It was 4x, that one looks easier to solve for, plus 2 times y, but I just found that y is 5. So 2 times 5 equals 9. So let's simplify. 4x plus 2 times 5 is 10, equals 9. Now I want to get x by itself and solve for it. So I'm going to subtract 10 from both sides. That leaves me with 4x equals negative 1. And then I just divide both sides by 4, which leaves me with x equals negative 1 over 4. So my final answer, remember, it's a point, so I'm going to go parentheses, negative 1/4, comma, 5, close parentheses, and that is my answer. Circle it with a galaxy pen. So now I want you guys to try this next problem, solving this system using elimination on your own. Let's go on to example 2 now. So we're going to solve this system using elimination. We're going to do this one together because watch this. Whoa, thought bubble. Dang, this doesn't look like it's going to eliminate straight away. Maybe if I multiply. You can look at this right away and see x plus 5 equals x plus y equals 5 and 3x minus 5y equals negative 1. There's nothing that's going to cancel straight away if I just multiply. There's nothing that's going to cancel straight away if I just add or subtract. But watch this. What if I take this top equation and multiply the whole thing by 5? If I multiply the whole top equation by 5 and distribute, look at this. 5 times x is 5x plus 5 times y is plus 5y equals 5 times 5 is 25. And now what was my second equation again? It was 3x minus equals negative 1. Now we can see if I add these two equations together, my 5y's will cancel out because I have one positive 5y and a negative 5y. So let's add these two equations together now. Plus, boom. So 5x plus 3x is 8x. 5y plus negative 5y cancels out, so that's gone. And then 25 plus negative 1 is 24. And so now we can solve for x immediately by dividing both sides by 8. And so x equals 3. Now all we have to do is take this, x equals 3, plug it back into an original equation. I'm going to choose x plus y. I'm going to choose x plus y equals 5 because that one's easier. So we're going to go x So I'm going to write that down. X plus y equals 5. But x is 3, so we're going to write 3 plus y equals 5. And then we're going to solve for y by subtracting 3 from both sides. So y equals 2. And so my answer is going to be parentheses 3 comma 2. And there it is. So now you guys try the next one. Let's go to example 3. Solve this system using elimination. We got 2x plus 7y equals 4 and 3x plus 5y equals negative 5. Thought bubble here. If we just multiply one equation by a number, nothing's actually going to happen here. But look at this thought bubble. If we multiply both equations by different numbers, then we will be able to cancel it out. And what do I mean by that? Watch this. I'm going to take the first equation right here and multiply it by 3. And now if I distribute, we're going to have 3 times 2x is 6x. 3 times 7y is plus 21y. And 3 times 4 is 12. Okay? What was the point of that? Now watch. I'm going to take the second equation and multiply it by negative 2. So negative 2, I'm going to distribute that to everything in the second equation. Negative 2 times 3x is negative 6x. Be careful with your signs because we often forget about the negative signs. Okay, so now negative 2 times 5y is negative 10y. And lastly, negative 2 times negative 5, negative times negative, is positive, so it's positive 10. And so now that we've multiplied both of these equations by different numbers, we can see if we add our new equations together, the 6x's will cancel. So let's add these two equations together. And so 6x plus negative 6x cancels. 21y plus negative 10y is 11y. And then 12 plus 10 is 22. And now we can immediately solve for y by dividing both sides by 11. Boom! So y equals 2. And now let's plug this back into one of our original equations to get our solve for x. So let's do the first one. 2x plus 7y equals 4. Instead of y, I'm going to put 2. So 2x plus 7 times 2 equals 4. So 2x plus 7 times 2 is 14 equals 4. And then let's subtract 14 from both sides. So I'm going to drag this over here. That leaves me with 2x equals negative 10. And then finally, we're going to divide both sides by 2. And so x equals negative 5. So my answer here is negative 5, comma 2. So 2 more examples here for you guys to try. Now look down here, very important. Remember our special situations. We can also get infinitely many solutions, or infinite number of solutions, and no solutions. So let's see how this would work. We can see on this first system right here, negative x plus 4y equals negative 10. And we have x minus 4y equals negative 10. So let's add these together because we can see we can cancel some variables out, or actually all of them. X plus negative x is 0, that's gone. 4y plus negative 4y is also canceled, so that's just 0 on the left side. And 10 plus negative 10 is also 0. So does 0 equal 0? Yes, it does. And so in this case, our answer would be an infinite number of solutions. Remember, if we get an identity, our answer is infinite number of solutions, or infinitely many solutions, whichever one you want to write. Boom! And let's look at our second over here. So we can see that it's a little out of order, so let's just rearrange our second equation actually. So instead of writing y minus 2x, let's put negative 2x, because look, we're going to drag the whole thing with it with the sign, negative 2x plus y equals negative 15. And my top equation, let's just leave it as it is, 2x minus y equals 5. And we can see if we add these two equations together now after rearranging, we're going to cancel out some of the variables. 2x plus negative 2x cancels out, gone. Negative y plus y cancels out, that's gone. So on the left side, I've got 0 equals 5 plus negative 15 is negative 10. Does 0 equal negative 10? No, it doesn't. So my answer here is going to be no solution. Alright, finally, of course, we're going to have another word problem, so let's write out this word problem. Let's read the directions here. So a group of 48 people, there's 48 people, came to watch Coach Goo, aka Asian Zeus, lay the smack down on somebody in a tennis match. There were 3 times as many children as there were adults. So we're going to write a system that could be used to find the number of children and adults in the group. So now let's write our two equations. What are the two things that we don't know the number of? We don't know the number of children, so let's say x is the number of children. And we don't know y, which is the number of adults. All right, but if I add together x and y, that's the number of children and the number of adults, that should be the total amount of people that came to watch, which is 48. So one of my equations is going to be x plus y equals 48, because of course the number of children and the number of adults together should be 48, the total number of people. Now there's one more equation that we need, and the hint is right here. There were 3 times as many children as there were adults, which means the number of children x is, or equals, 3 times the number of adults, because there's 3 times as many. And these are your two equations. And that's the end, guys, of notes with elimination. That was our last notes for this unit. So I'll see you in the next one.